So an electroscope supposedly allows you to see electricity or electrical phenomena. And so our example that we use, we've got the foam and the fur. So anyway, right now, get the tube charged up. Take a look at the leaves down here. Do you see them? You see what's happening? It's subtle. What's happening? As I get this close, the leaves go apart from each other. Huh, that's interesting. Why would that be happening? What could be taking place here? The foam tube is brought near the electroscope. It doesn't touch it. It's actually important that it doesn't touch. If it touches it, it could discharge to the electroscope, give it charge, and then that would kind of mess this up. Okay. At least what we're trying to see here. It would kind of mess it up. Okay. That is brought near to the electroscope. There are positives and negatives on the electroscope on that metal. Do those negatives want to be near the foam? No. What's the basic idea here? Opposites attract, likes repel. So where do the negatives want to go? They want to go away. So they're all going to migrate as far from there as they can get. Okay. And so by leaving, what they're doing is they're creating almost like a collection of positives then up at the top. Okay. Now, the two legs here, do they want to be near each other? All the negatives have been pushed onto them, right? They got your phone.
Yeah, sorry.
Is it not up there? Uh-oh. So these they don't want to be near each other, right? So what do? They're going to push away from each other like this. Okay? And so they exert force on one another, pushing each other away. They repel. All right. By the way, in the wintertime, when your hair gets staticky, not like humidity frizzy, but staticky frizzy, right? It happens to me all the time in the winter. It drives me crazy. But and it kind of like stands out. This is what's happening. It's the same thing. It's kind of like two strands of hair. They're both charged up, and so they separate. So what happens is you've got extra charge built up from whatever it is that you're doing, right? And so your hair starts to stand up. Same idea, right? So what has happened here? The same thing that happened when we were able to attract the magnet. We have polarized. This is polarization, right? The separation of positive and negative to become polarized. All right. I actually like this electroscope a little better. I think it's a little easier to see what's going on. So, again, I charge up the foam tube, and now I bring it near the top of this. Of course, now it's not working as well, but you can still see. Do you see what's happening? There we go. See how this piece in the middle is turning? I bring it near. The piece in the middle turns. So, I mean, what's going on here? There's this plate at the top, and that's connected to this piece. This is all one solid piece here. And then there's this piece that can turn. It's very carefully balanced, and it can turn. Okay, that can move. So when we bring the foam tube nearby, near the top, the piece that can turn moves. Okay, take it away, and it goes back. Your task right now is to use the charge diagram to explain this. It says positives and negatives on it. So we draw the positives and the negatives together. Originally, that's how it is. Everything's kind of balanced and neutral. And then we have our negatively charged foam tube brought near the electroscope. So when it's brought near the electroscope, the negatives all want to get away. So they go down here. Okay, and the positives are all going to collect near the top. And now the two, guess you call it the two legs of the X or whatever, like that, right on the bottom. They they don't want to be near each other, and they can move. So one of them does move. Let's see if I can do this. Oops. Oh, I turned off my pencil. So it turns and goes away. So that's what's happening with that electroscope. Any questions about that? Okay. Again, what is happening here? What is this process? Polarization. It's what happened to the other electroscope, and it's what happens to this electroscope. Which electroscope do I want to use? Let's stick with this electroscope for now. All right. So now I'm going to charge up the foam tube, and now I'm going to touch the plate at the top. Okay. Touched it. I can see there's like fur all over it now. And now when I take away the foam tube, what happens? It's staying there. What happened? Before we talk about the what's happening with the electroscope, let's just talk about the fur and the foam tube. What happens there? Right? When we rub them together, then the foam tube gets charged up. Okay. And so we would call that charge by friction. These are all terms that you're going to need to know. Right? So the foam tube is charged by friction. And so the negatives go onto the foam tube because they are rubbed together. All right, so it ends up with all these extra negatives. Now, right, so the thing becomes charged because it gains electrons. Right. Now let's talk about the electroscope. So it looks like this. We've got pluses, and because it starts off just neutral, nothing really special happening. Uh, all the pluses and minuses are together, right? They're all paired up. Then we have the foam tube. The foam tube is negatively charged. I'm just going to draw the negatives on the foam tube. All right. Now tell me about the negatives on the foam tube. Do they want to be together near each other? No, they don't want to be together. So, what was the difference this time? Oh, hold on. Let me correct this. This is like that at first. All right, it's together. Okay. So the foam tube, those negatives don't want to be near each other. Just like when you're charged up, you get a shock. So what happens is when this actually touches, what are the negatives going to do from the foam tube? They're going to go onto the electroscope. They're actually going to transfer to the metal. Okay. So I'm going to grab some of these negatives, put them on here. They're not all going to go on there, But what's going to happen is the negatives are going to kind of distribute themselves between the foam tube and the electroscope. And at first, the negatives are going to go away from the foam tube. Okay, so then I take the foam tube away, and this thing remains separated. Even when we take away the foam tube, why would this still remain separated? Right. Take a look at the electroscope now. How many charges are on there? Now there's more negative than positive. This thing has become now overall negatively charged. It has extra negatives on it. Do these negatives want to be near each other if they can help it? No. So they go to places where they can push away from each other. Okay. So again, some of these, notice that all the positives are matched up with the negative, but there are still these extra negatives. And so the extra negatives go away from each other, they push away, and that's what keeps the arms separated. This process that we just talked through is charge by conduction. That's not how you spell that. Sorry, conduction. So conduction, I want you to think contact. So conduction is when something becomes charged by making contact. I want you to watch what happens here. I'm going to charge up one side of the ruler. Set this down. Now, the tricky thing is it gets attracted to the table. Okay. And I'm going to charge up this side of this plastic piece. So they repel each other, right? But when I hold it up to the other side, we don't see any interaction. It's only the two sides that got charged up. If anything, there's a little bit of attraction there when I hold it up. So what does that mean about the charge on this? The charge on these things? Are the charges moving freely from one side to the other? No, they're kind of stuck in place wherever they are. Is that what's happening with the electroscopes? No, it's not what's happening with the electroscopes. The electroscopes, it's able to move. What's the difference? The difference is the material. So the electroscope has metal on it, right? So the metal of the electroscope, how do you spell that? Electroscope allows charge to move freely. Okay. This is a conductor. A conductor allows charge to move freely. So it's a bunch of vocab terms here, right? Charge by friction, charge by conduction, polarization, conductor. An insulator does not allow charge to move freely. So, for example, plastic. All right, and we can see that through our examples with the electroscope, with the foam and the fur, and the plastic pieces. Okay. All right. Again, a bunch of kind of new terms, but it's really just vocabulary.